Live now.
All right. So, did I have a quiz?
And you guys said nobody. You guys didn't have any questions with the homework or anything. Everything was pretty.
Yeah, and I just had technical difficulties with my computer. That's it.
Nice.
Yeah, it went pretty smooth for me.
Yeah.
So, I mean, it was mostly just the same concept, just different variables. So, it wasn't that hard to. Okay. Question 3. Are y'all into the question?
Yeah.
Yep. Okay. Question 3. In a pie chart, why are the slices sectors different sizes? The size of each slice is random. The size of each slice is determined by a number of categories. Each slice represents a category, and the area of each slice represents the portion of total occupied of the category. C, right?
Yeah, it's C.
Okay.
All right.
Okay, go ahead.
Okay, how are bar charts and Pareto charts related? Am I pronouncing that right? Pareto?
I think so.
Yeah.
Doesn't sound bad to me. So.
Pareto charts are constructed from tossing a coin several times. They're identical. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are largest to smallest, going from left to right. That's
C, right?
Yeah, I think it's C, isn't it?
I think it is. Yeah, I read something about that.
Okay. We could use P is normally distributed if NP is greater than or equal to 10. Is P the true proportion of the sample proportion? Same proportion, true proportion. Sample proportion, true proportion.
It's the true proportion, right?
I'm not sure.
Because the sample portion is with the little arrow thing over the top, just like X for standard deviation. X with the line was the sample mean, and then mu was the true mean.
Yeah, it's in one of the blue boxes. I sometimes skip over those in reading. I shouldn't do that, but I did.
So the P with a little line over it is the sample proportion, and then just regular P is the true proportion.
Yeah.
Okay.
What is M? The number of successes, the number of candidates in an election, the sample size. And that's the number of candidates in an election.
No, sample size.
That's the sample size. I'm sorry.
Yeah. I was like, wait, what?
No. The number of is what I got caught up in that. Like the number of people. Yeah. No, sample size. Right.
That's the one blue box you did read.
Yeah.
If P equals 1/4, what is the smallest n that satisfies the requirement? Hold on. So that's where we do the NP. It has to be greater than or equal to 10, right? 10, so it would be 40.
So yeah, the smallest it could be 40. But 40 minus what is P is a fourth?
Yeah, so
it'd be 40.
Yeah, because it has to follow that one where it's n times P is greater than or equal to 10, and then it also has to satisfy the n, and then in the parentheses, 1 minus P is greater than or equal to 10, right?
Yeah.
Okay.
So yeah, 40 would be the right answer.
That's the one thing that kind of threw me off a little bit, because normally it's just like, oh yeah, it equals whatever, you're good to go. But this one you have to have 2 different calculations to make sure it qualifies.
Right. Okay, next set of questions. Use the following information for the next 2 questions. Suppose n equals 24 and p equals 0.4. What is the mean of p? Round your answer to the 10th place.
Isn't it just 0.4?
Isn't it?
Well, P would be the proportion. It doesn't necessarily mean the means, right?
So I pulled this up again. 3.2.2. It says mean of P with the thing over it is equal to P.
Okay, so yeah, it must be 0.04 or 0.4.
If it's normally distributed, right?
Right.
Or if n is large. In this case, n isn't technically large because it's only 24 and we were using 30.
You're right.
So would we have to use that? Well, hold on. I don't even know.
This is the P over N.
Yeah, so is this the hold on, the x over n? Is that what we're looking at?
X over n would give us standard deviation, right?
Well, the standard deviation is the p times 1 minus p divided by n.
Oh yeah, now we need to find the mean.
X over n. Okay, so then x would be 0.4, right?
Divided by 24 equals, because I'm looking down at the summary. That's usually where I go for like all the formulas and stuff. It says p with the line over is a point estimator for true proportion. P with the line over with the little thing over equals x divided by n, and then x I believe would be that 0.4.
So if the mean of p, I got 0.016 or 0.017 if you round it.
But yeah, I got 0.017. Well, it says to the 10th place, so isn't that 0.0?
0.0.
The 10th place is the first one, isn't it?
Yeah.
Yeah.
0.0, but that doesn't. Does that make sense?
Unless it was 0.4.
I think it is 0.4 because.
Okay. Is there anything in here about how big is big enough? Because it's all I know it referenced the central limit theorem, but that doesn't talk about how big it needs to be.
Looking that up right now.
I don't remember anything about the mean. Like anytime they asked us to find the mean of something, we had to convert it into a z and then use the p values and stuff like that. But I don't remember reading specifically like.
So it does say you may want to refresh your memory on normal distribution.
Okay. Here it is. So yeah, what Matt was reading earlier. Okay, mean and standard deviation. The sample proportions of p is normally distributed if n is large. The true population mean and the random variable is p equals p. Right, that's the mean.
Right.
But that's if n. Okay, so and then it says answer the following question. Consider exercise 1 in which you toss a coin 25 times and recover the population. Blah 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 blah. So this is the mean p. So it would be, so p is 0.5 in this case because it's a 50-50 chance of flipping it. So with our quiz, well, that doesn't really help. I think it's just 0.4, to be honest. That makes sense to me.
Yeah, the information we were given, 0.4 makes the most sense to me just because we didn't really learn, I don't remember a formula for the mean in this reading. But I think I did skip at least one blue box, so I might be wrong.
Well, so here's another question. Going off the formula for p equals x times divided by, well, wait, never mind, we're looking for p, huh? What is x? X is the number of times it's observed.
Yeah. So x is any.
So what is that p equals? So if p equals 0.4, that means that 40% of the times whatever variable happened, right?
Yeah.
Yes.
So would it be if p is equal to x divided by n? Wouldn't it be shoot, what am I trying to say?
9.6 would be x.
9.6. That's another time. It would be 9.6 would be x, so divided by, so it'd still be 0.4.
Yeah.
So p does not equal x, then. So you'd have to use the two of them together to find x.
So are we saying 0.4?
Yeah. Yeah.
It's not like a straight answer. It's more of a guess, and you don't feel sure about it.
Well, right, because that's the thing. Because it says it has to be large. Well, the whole thing we've been reading is that it has to be at least 30. But the only problem is it doesn't tell us if it's normally distributed or not. I don't know. We can try it and see what happens, and if not, we can ask Matt's sister.
That's true.
So standard deviation of P. Well, see, this is question 8 is going to affect what we get for question 9.
No, because this is that formula, the P times 1 minus P all divided by N, all square root of that.
Right, but if we put that P is 4,
I see.
0.4 or 0.0, it's going to affect whatever we calculate in this one.
Gotcha.
So, because here's my issue with just taking the 0.4. If you look under 3.31, where it says the worked example, the probability of something happening in this case was 0.5, but the p-value, because they actually gave them a number of times that it actually happened out of 25, the p with a line over it was actually 0.68. So when they went to go do the calculation, because if you have 0.4 minus 0.4 or whatever we got, you're going to get 0 divided by whatever to get a z-score. That doesn't.
Nobody.
You having fun there?
My kid's bashing on my laptop.
Yeah, kids are like that.
Yeah. He's trying to tell me he's bored. He wants to go do something. Okay.
Hey,
so
we're right there with you, buddy.
Yeah.
Okay, so for number 8, see, and that's the other thing. Like, yeah, why do they give us X if they didn't really define what X was for the proportions? You know.
Well, so if it is 0.4, the answer is going to be 0.1 for 9.
That's what I'm getting.
Getting what?
0.1 for
8
question
is 0.4, then 9 is going to be 0.1.
So using 0.4 and 0.4, you got 9? Or you got 0.1, sorry.
Yeah, if it is 0.4, if P is actually 0.4, then 9 would be 0.1.
We can try it. I mean, we'll try it and see what happens. If not, then we know we need to go back and look at it. That just seems weird, because if you have 0.4 minus 0.4, you have 0 divided by who knows what.
Well, it's 0.4 times 1 minus 0.4 over the square root of 24. So.
Oh, never mind. I'm looking at the z-score.
Yeah, not the z formula.
But yeah, okay.
Yeah,
we can still get standard deviation, but once we get to the z-score, that's where it's going to screw us up. Not that we have to do it for this question, but just in general. That's why I was thrown off. Okay. So 0.1, I got the same thing. I threw it into my little thing.
Okay.
Yeah.
Okay, moving on. Question 10. Use the following information for the next 4 questions. Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 at bats. N equals 100 and P equals 0.3. What is P? Round to 2 decimal places.
0.05.
How did you get that?
So we're looking for P. So that would be the that formula we just did, the square root of P times 1 minus P all divided by N.
You lost me.
Oh, okay, yeah, because the earlier question just threw me off because it's The earlier question was asking what the mean of P was. This one's asking what is P. Okay, so yeah.
Hold on. So actually, 0.05 would be 11 because that's the standard deviation formula. Is what I did. So 10 would probably be 0.3. But that can't be right. Hold on.
No, because okay, let me find a definite definition for this. So P with the little arrow over top is just the sample proportion. Okay. So if she's up to bat, it's a 50% chance that she'll hit the ball or that she'll miss the ball.
That's P. That's
right.
But that's not P to the with the little line above it. That would be P, like regular P. So, and I think they got 0.3 because she's only batting a 0.3, so they took that as her average. If you look under 3.3.1, it says, note, if a coin is tossed n equals 25 times and the head is observed 17 times, the sample proportion of heads is P with X divided by N. So would it be 35 divided by 100, which would be 0.35?
Ooh.
If that's what she's trying to find out, would be what's the chances of her hitting a 35 out of 100?
I think you're right.
Yeah, because then when we use the equation to find the Z form, then we'll have something to take away from the 3. So yeah, so 0.35. That makes sense.
And then so the value of P with the line over it's 0.35. P is just 3, and then 100. Is that what you guys are getting?
Standard deviation, Bruce. Standard deviation for P would be that formula that we used before.
Which would be 0.046 is if my formula is right.
Oh, hold on, mine's not.
Let's see. 0.046.
But you plug it? You plugged in 0.3, correct? Not 0.0 or 0.35.
I did not. Yeah, I'm gonna do that.
Yeah,
so I got 0.0458.
Yeah, that's what I'd had before. But where it says to do 3 decimal places. Oh, you got 0.48?
I got 0.0458.
Okay, yeah. So I just rounded up to 0.046.
Yeah. Okay.
So 0.046. And then 12 is what is the Z score? Is that going to be I got 1.09.
So for the Z score, it would just be the 0.35 minus 0.3 over the standard deviation, the value we just calculated, right?
Yeah.
Okay.
Yeah, I just have all mine built into the same formula, so.
Okay. Yeah.
Let's see.
I got 1.09. Let me know what you guys get.
So 1.09.
Yep.
Okay.
Yeah, I didn't get that. Must have something wrong. Hold on.
And so probability
0.34. So it'd be 0.34 subtracted by 0.3.
No, 0.35. 0.35.
Oh, okay.
That might affect your calculations a bit.
Not by much. Okay, what am I getting wrong? So 0.35 subtracted by 0.3 divided by that 0.0458, right?
Yeah.
All right, let's see. Oh, you know what? I know what I did wrong. This subtracted by order of operations. I messed it up. Yeah, 1.091.
Yeah.
Something like that.
Yeah.
Okay.
And then the probability would be at least that, so it'd have to be the right tail, which I got 0.1379 for the probability.
I got the exact same.
What did you?
Technically it's 0.138.
Yeah.
So we took the z-score of 1.091 and put that into the normal probability outlet, right shaded it, and it got 0.1379 or 0.138.
Okay.
Hey, look, it's the first time we've used that thing in forever.
Right.
They keep giving it to us, and I feel like we're missing stuff because we're not using it, even though we don't need to. Standard deviation of
sorry, what did you guys get for 13?
0.138.
0.138. What am I getting wrong here? Oh, there
so
we go.
I got 0.1379, but then you just rounded to the.
Yeah. No, I had both sides selected. That was my problem.
Oh, okay.
All right. Using if the true proportion of people who support a political candidate is P equals 0.52 and N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of P? So
standard deviation, that's the 0.011, right?
I got to put it in. Well, what is P with a little line over it? It would be would it be? Well, I don't even know.
So standard deviation is that square root of P times 1 minus P divided by N.
So yeah, I got 0.011 for that.
Yeah, that's what I have.
Okay, hold on. Sorry, I confused myself with my formula. So it's 0.52.
Yeah, it's weird with the P's now because I'm never sure which one they're actually talking about. So.
Yeah, there are 26 letters in our alphabet. They should just pick another one.
Right. Next to each other for crying out loud. C and then U and V. I don't even care. What is it? You guys got 0.01111?
Yeah.
Z-score.
Now for Z-score, we need to know the P with the line over the top, right?
So
yeah.
P for the line over the top would have to be it. So sorry, I got an itch. Okay, so the true proportion is 0.52, but then it says later on that we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the vote. So P with the line over it can be
0.4999.
4.49. Yeah, it just needs to be less than 50%.
So what we do?
Sorry. I think you would put in 0.5, and then you would do the left-handed. Yeah, the left tail when you're getting the P value.
So when I put in 0.5 for the P with the line over it, I'm getting negative 1.79. Is that what you guys are getting?
No. Hold on.
What are you getting?
I'm not getting anything. Hold on. I'm trying to.
Oh, okay.
0.52 divided by answer. So yeah, I got a really big Z-score for that. That doesn't work for me. Why is that not working? So what did you guys use for your sample proportion?
0.5.
0.05 or 0.5?
0.5.
Okay. Did you get for a Z value negative 46 point something?
Nope. So I put so my formula is 0.5 minus 0.52 divided by the standard deviation of 0.01111.
Type this all back in. 0.5 minus 0.52 0. Negative 1.818.
What was that? Sorry.
I got negative negative 1.818.
I got negative 1.79.
Oh, yeah.
Are you?
I used 0.011, so yours is probably more accurate if you use the actual standard deviation.
Yeah, I just use the whole number. I don't round anything till the end.
All right, 1.7 what?
9.
1.79. Is that what you guys are saying?
That's for my Z-score, yeah. And then if you plug that into the probability applet, left shade it because you want the thing of it showing less than that. You get 0.0367 is what I got.
Okay.
0.0367, yeah. What is the probability the survey results will show the candidate is losing even though the true P is 52? Is that just a 0.037?
For 16? Yeah. So 0.037 is what I would put because, well, rounding.
Right. All right, I'm submitting it. See how we did.
Okay. So let me make sure I've got this right. So 15, you guys got 1.79, and 16 was 0.037.
Negative 1.79.
Oh, okay.
And I got them all right.
Yeah, same.
Nice.
Woo!
Good job, guys.
So, okay, so then review on that one. The mean of